Azure Cosmos DB enables incredible speeds, provided you choose the data model that best supports how you use your application. Data modeling is the process by which you establish patterns and rules for storing data across documents and containers, determining how data is accessed. Choosing the right data model for your workload results in better performance and faster speeds, especially as your database grows. While there are many nuances to data modeling, every project starts with the same question: whether to embed or reference. Embedding, also known as denormalizing, allows you to combine related entities into a single document. When used with read-heavy applications, results come in fast and ready to serve, no joins required. Embedding often leads to data duplication. With Azure Cosmos DB, duplications aren't a problem. The Azure Cosmos DB change feed helps maintain referential integrity across containers. Embedding falls short, however, when there's no practical limit to how much data will be stored and you reach the maximum size for a single document. It's also not ideal for write-heavy applications because it can lead to bottlenecked requests. In those cases, it's better to use referencing or normalizing like you would for a relational database. By creating unique entities that reference one another, you can break up write requests and break down large documents to speed up your application. Enable top speeds and seamless experiences at any scale with Azure Cosmos DB by implementing the right data model for your application from the start.
Hey everybody, my name is Jay Gordon. Welcome to the Azure Cosmos DB Global User Group meeting for this September of 2022. I am really glad you've joined me. We've got a ton to talk about today. I've got a really great guest. We're going to learn a lot and in just a short period of time. So we got an hour together, and so I'm not going to waste any of that hour. So I'm going to bring my guest right away back into the screen. It is Sarah Dutkiewicz. I got it. Yes, sorry. I have this I'm here from Brooklyn, New York, and I have this marble mouth New York accent that sometimes I got to take a couple times to get something right, but I did. Welcome,
You did
Sarah.
get it.
How are you?
I'm
How are
doing
you
fine,
today?
Jay. How are you?
I'm good. Just enjoying, being back. I took some time off the last few days. It was the Labor Day weekend here in the United States, and so a lot of us got a chance yesterday to kind of sit back, reflect on how much labor that we do. And first of all, thank you for giving us some of your labor today by helping us present on today's subject. It's really super helpful to have members of our community, which you are one of the champions in, to come and to help out the community learn more and more about Azure Cosmos DB, the different implementation methods, things like that. I really appreciate it. Thank you so much.
Oh, sure. Thank you for having me.
You got it. So we've got a lot to talk about today, and we're not going to waste any time. I'm going to give you a chance to talk about today's subjects, which are graph databases and how data modeling works with that. That was one of the reasons I just showed that video. I love that video on data modeling. It gives you just a brief, 2-minute explainer, but then we'll talk a little bit about a specific data model methodology around Gremlin API for Azure Cosmos DB, how the Apache Tinkerpop project kind of fits in, and we'll learn a ton more. Now, Sarah, I'm going to ask you some questions, and I want to let everybody else know, if you're going to have questions, leave them in the chat, and we'll address them as soon as possible. We want your participation. This is a user group session, which means you, the users on the outside, we need to hear from you. So send questions, send any information, comments, things that you have during the session, and we'll be sure to get to them. I also have just a couple small things to talk about before we get started. First of all, we are being, this meeting is under the Microsoft Event Code of Conduct. That code of conduct is available at aka.ms/code of conduct. We expect all participants to uphold the principles that are listed in this code of conduct, be good to one another, and use this space as a positive place to learn and share. So if you'd like to take a look, aka.ms/code of conduct. Additionally, if you'd like to get lots and lots of resources on Azure Cosmos DB, we have this great developer resource page where you can find out about customers using. There's all the information about the different APIs, and the one we'll be talking about today is this guy. And if you'd like to get started, we have this introduction to Gremlin API in Azure Cosmos DB. I'm going to put all these links in the chat, and they'll be in the video description as well. So we've got this one, and then we've also got another great page for you to check out, graph data modeling for Azure Cosmos DB API. All this is just really great complementary information to what we're going to get from Sarah today. But before we do, I want to ask you a little bit about yourself, Sarah.
Sure.
One of the things that's great about doing these types of sessions is like being able to take a minute to learn a little bit more about our community members. And I'd love to hear a little bit, Sarah, about one, how you came to doing what you are doing nowadays, which is amazing stuff. You're doing tons of presentations. I'd like to hear how you got here.
Okay. Well, I got into the whole presenting thing thanks to a Microsoft developer evangelist way back when, and talking like 2008, 2009-ish. He was out there talking about developer technologies that Microsoft was dealing with and said, "Hey, you showed an excitement at a user group. Why don't you consider maybe speaking at a user group?" I was kind of like, I did that once before. I used to speak at a Linux user group back in college. And
Hmm.
so took some time off to finish my degree, came back home, kind of forgot about the user group thing until my husband was just like, you know what? He's like, you need to get out speaking again. So between him and the developer evangelist, I was like, okay, fine. Developer evangelist guy introduced me to a bunch of other folks who also organize conferences and speak at conferences, and the rest is history. I've just kind of built a network over the years with that. My topics are all over the board, from developer, DevOps, IT
Hmm.
pro. Um, I don't stay still in one lane, that's for sure.
Yeah, well, that's the thing. We got to be agile, right? To be able
Absolutely.
to pivot on a dime, and DevOps our own lives, if you will.
Yep. Yep.
That's kind of the way I look at it. And so sometimes it's very worth to have a diverse set of skills to kind of talk to people about, whether they're members of the community, people who are looking to become a member of the community, and peers. Just being able to share all this important information. So I have one more question before we get into the technical bits of today.
Mhm.
You have the Twitter handle and a little, I guess, nickname of Saduki. Where did that
Yes.
come from?
So as you saw with my last name, it's not really an easy one to pronounce.
Hmm.
So Suzuki actually started as a couple nickname. My husband's last name is Dutkiewicz. I took it when we got married 18 years ago this year. Been with him 25, so
Congratulations.
we've been together for quite a long time. The Saw is from Sarah, and Dookie is his long nickname. He was always Dookie or Duke. And when we got married, I asked him, like, can I just take the Suzuki nickname as myself? And he gave me his blessing, and I've been running with it since 2004.
Spectacular. Well, that was a nice little story to just hear the background of that, because like I
Hmm.
always see a Suzuki and I'm like I can kind of guess where it came from, but I wanted to make sure I heard everything.
Oh, absolutely. And the coupled nickname started with a group of us in college. We're trying to figure out where to go out to eat. And we were an
Mhm.
even number of people, and we were split down the line. And our friend Pete said, "Hey, the Sudoku counts as one vote." And we're like, "Wait, what did you call us?" So that's how that came in the first place.
That's great. So we've got a lot to talk about today when it
Yep.
comes to graph databases. And graph databases are really great for creating associations between different types of data.
Hmm.
So one of the more popular ways of using graph databases tends to be things like social media. Um, I know putting, like, say, buyer preferences
Hmm.
and in web
So
stores.
recommendation engines.
Yeah, like recommendation engines. And there's so many other use cases, and I'd love to hear a little bit more about that. And so I'm going to bring up your presentation and let you kind of get started.
Sure.
If you've got questions, anybody, please put them in the chat. We'd love to hear from you.
All righty. Well, and the data that I'm going to use for the demo is from a conference called Data Weekender that I did earlier this year, representing Cosmos DB, because come on, people, this is awesome. This is fun stuff. So let's talk about the Gremlin API, also known as talking about graph data. Some of the things we want to look at are like, what are graph databases? What are they used for? What are some components, the modeling, the API? And then we're going to get into the query, the loading the data part. So this is based off of a presentation I've already done before. So I have scripts there for you to use in your own Cosmos account. So we'll talk through how to access that. I have a link going out on Twitter for that. So Jay heads up on that as well. And then we'll talk about graph traversal. But first things first, what are graph databases? What are they even used for? So to give you background, I come from a relational background. I came from SQL Server. I was a DBA for SQL 6.5, SQL 7, SQL 2000, into the modern days as well. I got dropped into an Azure Cosmos DB project, and I was like, oh, okay. I see, this is not the SQL I'm used to. But then I saw this Gremlin API and I saw the data thing. And as soon as I saw that Gremlin API, I'm like, oh, I know what data is, what graph data is, because I draw it out so much when I explain concepts to people. Graph databases allow you to explore relationships between entities. So as Jay was talking about, like buyer preferences, recommendation engines, social networks. So an example I have for that is, think of something like LinkedIn, where you're connected business professionally to other people. So for example, I know that Lenny Lobo does presentations for Azure Cosmos DB. I don't know him personally, so he is not a first degree connection, but I can learn about him through Jay or through Mark. So that would be like a second degree connection. Things like that. Symbolic reasoning, so actually drawing out concepts and explaining relationships with those. Identity and access management, knowledge graphs. Fraud detection is another thing that uses graph databases. There's a couple other management things and situational awareness too. So if you're in a situation you want to understand more about it, that could be helpful. So today I'm going to talk about a basis for a recommendation engine, looking at a conference, the talks that are there, the subjects that are there, the tracks that are there, the times, things like that. But before we even get into the queries, before we get into playing with the code as developers, that's what we do. We love to play with code, but hold up. We have concepts we need to understand ahead of time. So there's terminology. Thankfully, the terminology is short and sweet. We have vertices, we have nodes, and we have entities. So vertices, nodes, entities. Those are the terminology you'll hear for the things. They can have properties. So I've got this kind of graph where the Data Weekender conference covers various topics, including Power BI, Azure, and SQL. And then it could have various people who are interested in these topics. For example, you may be interested in SQL, or you may be interested in Azure, you may be interested in Power BI. This talk fits in there somewhere as well. The other thing to keep in mind, so we have vertices or nodes or entities, or like I call the things. We also have edges, which are the relationships. How are things related? So in a relational database where you have relation of like tables, this is actually a relationship of things that we're looking at. Now it's directional. So we're talking about paying a close attention to where those arrowheads are pointed. So for example, you may be interested in Azure, and Azure is a topic, and Data Weekender covers that topic. These edges can also have properties. And then the last piece of terminology, so vertices and edges are going to be the ones you'll hear a lot about today. Graph, the graph is the collection of those vertices and edges. And what you're seeing here, this visualization, this is just PowerPoint and shapes. This is not at all what you're going to see in the database itself. Now, the Cosmos tools are awesome because it does have graph rendering for us to play with in Azure Data Explorer. There are also other tools out there as well. But again, before we get into writing code, understanding these things like the relationships and their direction. What does it mean with the direction? Well, relationships or edges, they can go in or they can go out. I should say they can come in and go out. So this is looking at a perspective so you can see what's going on. We're looking at the topic. The edges in this case are going into the vertex. The ISA, that is the label of the edge. So understanding the relationship of ISA. Hey, Hassan. From the topics vertex, looking at that, they're all pointing at the topic. So ISA is an edge, what they call an in, pointing in. Now, these ISAs are coming out of nodes. So the ISA is coming from SQL, is coming from Azure, is coming from Power BI. So looking at those vertices, the ISA edge is an out edge. So directions, it helps when you see, like if you draw it out on paper and draw out the two edges of that relationship, where is that arrow coming out of? That's the outside. Where is it going into? That's the inside. Bear with me on this because I'll show you where that is actually stored and why we need to consider that when it comes to data modeling. All right, so ins and outs. This is what that graph looks like as a whole. So you see that there is an ISA relationship. The arrows pointing again at topic are the in from the perspective of topic, and then they're outs from the perspective of SQL, Azure, and Power BI. So this is looking at ins and outs with the vertexes. Now suppose that there are different types of relationships, which there are. Now we're going to look at edges then. So Azure in this case is the central vertex. It has a relationship coming into it. Interested is pointing at it, and then contains is coming out. So again, the one that's pointing at it, it's coming into it. That's the in edge. And then pointing out, that's your out edge. That's how I remember it. When I draw it out to look at it initially, it's okay. These relationships, entity, edge, other entity. When I draw it out, I usually say, okay, this is a thing, or this is a concept, or this is a whatever that entity may be. We okay so far?
I think we're doing great. I have a very basic question for you.
Sure.
Which I think is great for level setting. And so I'm curious, like, what are the big advantages of using graph over, say, relational or NoSQL, like standard NoSQL, like document?
Yeah, so under the covers, this is still a JSON document in Cosmos. But the difference is being able to query it using that Gremlin syntax and being able to query it. Like there's an example I usually have working that just got eaten by demo gremlins this morning, but it's the social aspect of it all. So it's I can do a search at one layer and see who I'm connected to, which is okay, but I want to see who do I know that knows people who do a certain thing? Like who else do I know that knows people who work with Gremlin API? Because I may not know somebody else who works with Gremlin API. So I would have to check to see who my contacts are. So navigating those relationships beyond the first level. First level, you could do that in a SQL query with relational tables and get you what you need. Two levels out, then you're getting into a little bit nested queries. 3 levels out, and then it gets a little more convoluted. And the query length gets longer and longer in SQL, whereas with Gremlin, you're just working with ins and outs. It's a little bit shorter, and it's meant to handle those kind of queries.
Gotcha. I think that helps get me a little bit closer to what I think that people watching want to hear and know. Like, hey, I really appreciate that. So why don't you continue?
Okay.
Feel free to let's move on.
Yeah, sure. All right. So all together, this is the interested in. This is the perspectives, the ins and outs. So with Azure, you see that interested in is in edge and contains the out edge. The interested in edge from the you have different perspectives. So U is the out vertex for the interested in edge, and the Azure is the in vertex. So outs and ins apply to both edges and vertices. And we'll talk about this more when we're going through some queries because I point that out in the queries. So if this is like, there's a lot of outs and ins, how do we keep them straight? Rest assured, queries are coming. But before we can get with the queries, let's talk with the modeling. So SQL, you're used to relational tables perhaps, and maybe bridge tables, join tables, cross tables, however you call them. So there's a question, can I ask a single copy of the data, access a single copy of the data via the Gremlin API and later use Cosmos SQL API? So you can query the Gremlin API with the SQL API using Hassan's tool. I've done it, but just because you can doesn't mean you should. Because the JSON structures underneath, when you query it, are a little more awkward. It's structured so it works well with the Gremlin syntax. So yes, you can access that data via Gremlin and later access it, but it's probably not advised to do that. Unless you need that JSON for some reason.
Makes sense. Thank you very much for answering this question.
Oh, absolutely. All right, so when it comes to data modeling, you want to understand a bunch of things with your models. You want to understand, how is that data going to be stored? How is that data going to be queried? And what relationships do you care? For me, when I'm working with graph data, I'm commonly in a relational database, and I'm like, I want to actually look at the relationships for some of these things. And so then I explore it that way. Well, going from one table to another, I'm not bringing in all of the properties because I'm specifically focusing on a certain relationship. I don't need all of the details that's stored in the relational. I only need what's related to those relationships. So when I understand how that data is stored for the graph database, something to keep in mind, Azure Cosmos DB stores their out edges with their respective vertices. So I have my U vertex. My interested in is going out. That's going to be stored with the U vertex. This makes a difference for queries. Sometimes you need to have multiple directions on your nodes to make your queries a little more efficient, but that's going to be something that you'll learn as you work with your data. Identifying the relevant properties is key. You don't need to bring everything over there. Keep in mind, what are you actually querying? Are you looking for fraud patterns? Are you looking for social connections? Are you looking for interests? What are you looking for? Another example I like to use, so this is a conference talk, but I've also done stuff like, for example, wanting to buy a gaming system, like a PS5 or Xbox or something like that. Well, I had people who like to buy these things, but they don't know where to find anybody. And then I have friends who actually do purchase these things and then sell them. And so doing a network graph and showing that, they're like, oh, that's how that works. It's pretty cool. But the other thing you also want to know is reading and writing usage. You typically aren't going to want to do much writing other than loading the data. You're probably going to be querying a lot more to understand the relationships therefore. So it's going to be more read heavy than write heavy. Typically, I haven't seen any super write heavy Gremlin API usage though. But yeah, this will help you to understand, how are your entities being used? How are your things, your vertices going to be built? Something else to know is partition keys, which you see in other Cosmos DB APIs as well. They are used for horizontal scaling. They apply to the vertices in terms of the Gremlin API. But you want to use a field that's going to be evenly distributed, so that follows the same way here. You cannot use ID or label as the partition keys. It will get called out if you try to create it like that. This is a screenshot I have from the Azure Data Explorer, so the Azure portal. But if you tried to do that via the command line, it would complain as well. And then this more guidance, your data partitioning with Gremlin API. Jay, you had that link up earlier at the beginning of this talk. If you want to bring that back up.
Yeah, sure. Give me one sec. So this is the graph data modeling for, yep, there you go. Graph data modeling for Cosmos DB for Gremlin API. You can go to aka.ms/graph-modeling.
Yep, and that graph modeling does include links to the partitioning as well. So, all right. So that's the partition keys. Let's go look at the Gremlin API itself. Oh, I do see that there's a question in the chat about OpenCipher. It looks like you got that taken care of.
Yep.
Awesome. And for those not familiar, Cipher is another language that's used for querying graph data. All right, so Azure Cosmos DB Gremlin API. Well, here you know that Azure Cosmos DB is already a multi-model database. The Gremlin API is that graph database implementation. So you've got your column store, that's Cassandra. You've got your document DB, that's the API for MongoDB. You have the Gremlin API. You have the table API. And then, of course, the core SQL API. Gremlin API is your graph. The demos I'm going to show you today involve querying with Azure Data Explorer. I love being able to show this in the browser because I don't have to get into the API libraries and get wielded with a bunch of questions on code. Like, oh, why did you do it this way or this other way? Why are you using this pattern? We don't need to have those conversations. We want to focus just on the Gremlin language. However, there are graphs that you can build with the API libraries. So I may show you the Gremlin Python and how I loaded this in the first place. All right. At this point, I'm going to switch over to Azure Data Explorer. The slides are here, but when Azure's cooperating nicely, I'd rather just go into a live demo.
Sure, we'd love to see it.
All right.
Remember, everybody, if you have questions, just leave them in the chat and we'll address them as soon as we can. Thanks very much and appreciate the ones we've already got.
All right. So we are currently looking at my Cosmos DB, specifically the Gremlin API. We know that I'm looking at Gremlin API because of this left navigation here, where it shows Gremlin API. I've got my conference demo database and my data weekender container. In the screenshots, you'll see other things as well. There's a question about calculations of transaction data on top of data present in the graph. So we'll look at some calculations, some aggregates a little bit later. There is some that you can do. The question will be, why do you want to look at that? All right. So this is Azure Data Explorer. This is the Cosmos view. But if you go into your Cosmos resource in the portal and go to Data Explorer, you'll get an UI similar to this. So Gremlin API, going into the graph section of my container, I'm going to collapse the tree on the left to give us more to see here. Okay. So this is where we start with Gremlin. So remember how I said V for vertex and E for edge? Vertexes and edges are keywords. And you will hear me say vertexes or vertices. Either are correct. G. So let me maximize that one more up. So that G here is for graph. And g.v is going to get me all the vertices in my graph. So if I do that, I'm going to tell it execute Gremlin query. You're going to notice, and I'm going to scroll past my query so you can see there's some grossness here. I always call this gross because goods are gross. They don't really help us when we're actually looking at trying to make sense of our graphs. And if I click on these, you'll notice that there's this graph section. Let me expand the graph section so you can see. This is a graph of goods. So gross. However, we can fix that. Up here in the style, we can show the vertex node as, so right now it's showing as IDs. IDs don't make sense for us humans. We need to actually see something sensible. So let's show the name. And notice as I change the name, my graph behind is showing me some names. And then we're going to change our node color based on the label. I'm going to close this. All right. We'll talk about labels here in a minute, but I just wanted to show you getting started with this. What does this look like? It goes from IDs, come under style, change it to some field names. Now, the first thing I did was I changed this so that we're looking at the name so it's readable. And then I also changed for our colors. To scroll it down a little bit. So we have some of our graph. I'm going to select the SQL node. And I'm going to open up the properties on the right-hand side. The ID, there's our good. And then we have the label. The label, I also use here a field called type. Just playing around with properties on that. Then we have our name, which is the name that it shows. That's the property here. Now, there are things called sources and targets. So I mentioned in and out, which we will see in queries, but sources and targets are what you're seeing here. There's no sources, but my target. So SQL has relationships coming out of it and going to, and you can see that there are topics that are database projects 101, for example, is a target. So these here, these are your out vertices for these relationships. Or no, those are the in vertices. Oh, that's where the arrows are pointing. So if we follow from SQL, and if we were to come over to here, database documentation done the easy way, for example, you can see its properties. If I go back to SQL here, so you can see where it falls under that. So database documentation done the easy way, the edge is labeled contains. The edge labels do not appear in the graph rendering, but just so you're aware that that's there. Okay, I'm going to scroll back up. It's one thing I don't like with this query. Collapse my graph. There we go. Okay. So here we go with the SQL with the targets. The results, again, I can click on any of the nodes. What's neat about this too is I want to bring our graph back up.
Mm-hmm.
If you see these 3 dots on any of the nodes, you can use it to navigate to other topics. There's machine learning, for example. It doesn't look like the other relationships are showing on this particular one. We'll come back to those relationships when we get back in the slides. But just so you have a peek at how this interface works. So there's results, there's graphs, there's the properties. There's also query statistics. We'll talk about those later, and we'll talk about JSON later. All right, let's go back to the slides. I want to kind of keep them somewhat in sync.
Before we do, I think we
Yes.
have a question.
Sure.
Can we do any calculations with the transaction data on top of the data presented in the graph?
So calculations with the transaction data in terms of like counts and aggregates, things like that.
Well, we'll ask our person that posed the question to give a little bit more detail
Okay.
on that. So we'll get back to it.
Yeah, if we're talking aggregates, yes, you can do aggregates. The question is going to be, what are you trying to do with those aggregates and why? I do show a couple things, but not a lot, because typically that aggregation is more something I deal with in the relational side than here in the graph.
Okay. Well, thank you.
Sure.
And also, you had mentioned this doc before, but using a partition graph in Azure Cosmos DB, there is a doc right there and a URL that you can go to get to.
Yep.
So it's demo time, huh?
More demo. So I showed you this. These are my backup slides in case Azure decides to not cooperate. So I'm going to scroll past them. Rest assured, we already were looking at these. As you can see, I do videos in case Azure decides to not cooperate.
Oh, been there, done that.
Exactly. And the first time I gave this talk, I was at my cabin on Starlink. So I wasn't really sure how that was going to go. So I've made videos just in case.
Always a good idea.
Yep. All right, so what is Gremlin? Let's talk about Gremlin. So it comes from the Apache Tinkerpop project. You'll see this Gremlin guy drawn on all of their documentation. So shout out to Katrina Yim, who's their artist. There are various libraries that you can use to work with Gremlin. So Gremlin Java, Groovy, Python, Scala, .NET, and more. The one I use in this particular demo is Gremlin Python. I have a Jupyter notebook that uses Gremlin Python to load. I did a holiday version last December working with a C# application in Gremlin.net. I have a talk that's coming up hopefully for the Festive Tech calendar again this year, also doing more Gremlin. So
those guys are great that put that thing together.
Mm-hmm.
Gregor, I think.
Yeah, Gregor Suddy.
Yep. does a great job.
Yeah, that's such a fun group to work with. So I'm looking forward to submitting some talks to them this year, including more Gremlin, because I love Gremlin. I can't help it.
Well, we have from the Cosmos DB group appreciate it. So thank you so much.
Sure thing. All right, so Gremlin, again, that's from Apache Tinkerpop. You'll see it here. Azure Cosmos DB uses it. There are other databases that use it as well. They're all graph databases. So it's a pretty standard language. In terms of things that we're going to look at, so this is, you'll see commands, you'll see descriptions, and we'll talk through some of the, what does it look like? So G, you always start your queries with G. That's the graph. You want the collection of your edges and your vertices. G.V, you'll hear me say it over and over. V is for vertices, or V is for vertexes, or V is for vertex. So if you want a collection of your vertexes, you're going to query it with G.V. There may be a question about the case sensitivity, so let me pull that up so you can see, is that case sensitive? If I do G.V with a little v and execute my Gremlin query, it's still going to run it. Edges, G.E. You can see the little e a little bit better than a capital V. So in terms of case sensitivity in that regard, not so much. But suppose I want to do all of the vertices that are considered topics. They have a label of topic. If I do this and execute Gremlin query, notice I have 0 results. What happens if I put my capital T back in? There are my results.
Yep.
So in terms of case sensitivity, the data matters, but the G.V, G.E, the V and the E, it does not matter.
Good information to know. Thank you.
All right. So anytime you want to find a vertex with a particular label, that's when you get into has label. Now, the other thing you can do is search for properties. So let's do this. Let's look at, I'm going to pull one of my nodes up. So that's the database project. And I don't care about where it's at on the graph, so I'm not expanding graph. But I'm looking to see one of those, yeah, just stay selected. There we go. So you can see here with I have one of these are my talks. A talk, it has a relationship with a topic, but the talk has a name, it has a track property, and it has a time property. So we have some properties that we're going to be using in our queries, specifically other than name. The reason why I do other than name is so that you can see that that name is not the only property that we can work with. So say I want to find talks that have the track, and that are like track 2, for example. Notice that I don't have to escape my 2. I can leave it in an integer form, and I will get results. So that is fine. If I wanted to see the time at 0900, so I could say time 0900, I believe, has to be in quotes.
That's one.
The red messages of death. No.
I think there's a quote missing. There you go.
I actually need quotes on that. And so then I get the list of all the sessions at 0900.
We've got another question if you got a second.
Sure thing.
Sure. So Jacob wants to know, how useful would the graph be for building a user segmentation tool against their attributes than a standard SQL DB? Example, find all users with the name == John at && DOB. And then
greater than 20 years ago.
20 years ago, yeah.
So at that point, that's something that can easily be handled by a relational query. So if it's already in a relational database, I would say leave it there. It would be more for if you're going further depths of relationships outside of that. So looking at his query, finding all users with the name John, greater than 20 years, connected to other people who are older than and continuing on. Like if you needed to find who's connected to this person, who's connected to that person, like multiple levels of connections, then I could see going to graph. But if you want just all people who are named John who are greater than 20 years old, leave that in a relational database. Relational databases are better meant for that.
Great. Thank you. Appreciate that. And we appreciate your questions. If you've got more, go ahead and put them in the comments section. We'd love to
So
hear
if
from you.
including events and messages against a user, then a graph could be better. Including events and messages against a user. It could be, depending on what you're trying to do. So if you're trying to say something like a user sent an email to somebody else and doing maybe like email tracing, that could be a way to show it.
Very cool. Well, let me let you get back into it. We got about 20 minutes left.
Yep.
So I want to give you your time.
Good deal. All right. All right, so that's, and we looked at a graph response. We showed a graph and navigating with the 3 dots. The graph properties, so knowing that this is going to be your node name at the top. The properties include any additional properties we add to our nodes, including type, including name. Label and ID are standard. They're part of the vertex and edge. Sources and targets have to do with those relationships. So if we look at this example, for example, on edges, we have this Database Projects 101 and ADS talk. We have our sources and our targets. So our sources means that we have relationships coming into. These are our in edges. If we had targets, they would be going out. Working with edges, when we're querying edges, they do not have this graph representation. This graph representation is just so that we have something visual to see them. Edges, when we do queries specifically on edges, we get JSON. So that makes it a little more challenging because now we have to bring in, okay, we have IDs and values and things like that. So when we're working with edges, there's no visual graph. That's something though that you can handle in your application layer as well. Edges as sources. So you can see our SQL source, our Azure source. So those are coming in to database, but then edges as targets. We have our Azure node. Our Azure node, these are all topics that contain these talks. And so that's what this target shows, is that these are going out from Azure. We're on Azure. Out will appear under targets. In appears under sources. All right. For this demo, when it comes to loading the data, I have a Jupyter notebook using Gremlin Python to run this. You'll just need to include your endpoint, your database name, your collection name, and your primary key. These are all found within the Azure portal under your Cosmos DB resource. On the left-hand side of the navigation, look for the key icon, and that's where you'll find these values.
Wow,
So,
you know, that fits kind of the question that someone just asked. Is if they could have a sample notebook that can be used to insert data from a data frame using Gremlin Python.
correct. So this repo here, this link, I do also have tweeted on Twitter. It should be going, it's out already. I scheduled it for about 1:20 Eastern time today.
Yep.
But go to that link. That's going to go to my Data Weekender repo. It's got a notebook for you, which will be used to load it. That's what I'm using here. Again, I had some demo gremlins eat my initial demo, so I fell back to this one. Having that notebook makes life so much easier. So you will have a notebook to load it. And then the queries that I show you here, they're in this slide deck. This slide deck is also in that repo, so you'll have that as well. Things to note with loading the database. So I'm reading it in the data with pandas because the sample data is in an Excel file. So I read in the Excel file and then I query my vertices and my edges and building those. You're going to see that you can create vertices. I use themes and episodes depending on what I'm talking about. I've done this as a movie demo before, things like that. But with like foreign keys and relational databases, you can't build an edge until both of those vertices are built first. So it gets cranky. All right, graph traversal. So written from left to right, see it as a pipeline. We start as G We navigate with V to E, with in and out and both for their edges. Where can we run the queries? So you can run these queries as Gremlin API calls. I do this in my GraphMiss demo. So on github.com/saduki/graphmiss, there's a C# application using gremlin.net. So you can see me passing these Gremlin queries, the g.v syntax and the g.e syntax. But for the demos that I have in my slides and that I would run in the browser, Azure Data Explorer is where it's at for me. Why Azure Data Explorer? Because when I'm in a browser, sometimes I don't want to load additional tools. So this is a wonderful thing to work with. We'll go past the video. All right, so talking with relationships, we want to talk about in and out in terms of queries. So our vertex, I want to find the vertex that has the name Database Projects 101 in ADS. And I want to find all the edges that are coming into it. So that is in E. If I wanted to find the ones going out, that is out E. And then you can see I've included the graph representation because I know when you see the queries in E, out E, or when it gets a little more complex, as it will here in a few slides, in V, out V, in E, out E, how do you keep them all straight? Having that graph to trace through it makes a difference. All right, so I know we're running short on time, so we're going to skip through some of these in terms of live demos, but we'll talk through what they have. And then the same thing for edges, noticing things such as, my laser pointer, there we go. Okay, so g.v has database project. We want all the relationships coming in, so find the arrows that are pointing at it. These are your in E's. These are your in V's. Your out V is where are they coming out of. So this is the JSON response when you're querying edges. Your in V's and out V's have to deal with the directions. And again, for when you work with it enough, it makes sense, but sometimes you have to have that visualization to draw it out. You can find out your details, such as how many types of labels are there for vertices. So that's g.v.label. Same thing for edges, g.e.label. We can use dedup, so dedup, to just get the unique values for those. Dedup also applies, as you see here later on. You can do .values. So if you want all the values for a label, it would be g.v.haslabel.label.dedup. Values for a property, g.v.haslabel.values the property name in dedup. So I could see what tracks are there. Notice this isn't in any order. Order by is a separate thing. So this is just the order that it grabs from the data. So if you're worried about order, sit tight, it's coming. When you're playing around with this data, you may want to add your own to see how this works. So you can do that. When you add a vertex, it's g.addv. Give it the label name that you want to use. And then the properties, any properties that you want to add to your vertex are chained with property, the property name and the property value. So the example I use is we want to add a topic for Azure Cosmos DB. What does that look like? So g.addv topic, add property name. It's called Azure Cosmos DB and the type is topic. Notice here, I don't have to say anything about what the ID is on this. Azure Cosmos DB handles that under the covers. So all those GUIDs that we saw, nothing we need to worry about. At least not in this part. And then when it comes to adding an edge, you can see g.v.hasName, the addy. Then there's this 2. Let me grab my laser pointer so I can focus on that 2. This 2. You could also do it from, depending on how your mind handles the relationships. Specify which directions your relationships are going. And then in those parentheses, this will get you another vertex. So it's vertex to vertex. You could also do vertex.from vertex. All right.
We have about less than 10 minutes to go.
Yep, we're good. All right. So then this is talking about a new vertex and a new edge. When we add those, what does that look like? All right, now the question we had earlier about the calculations with the transactions, I think this might help them out a little bit, but if this isn't what you were asking for before it's a deep dive, please let us know. So when it comes to aggregating, there are some aggregates that are supported. And actually, Jay, I forgot a link. It's the Azure Cosmos DB cheat sheets.
Mm-hmm.
There's a cheat sheet for Gremlin that has all these different functions in there. So you don't have to go, oh, what is this again, and look it up. Use the Azure Cosmos DB cheat sheets for that.
Got
Awesome.
it. I'll
Those
be
things are
sharing in
awesome.
just a second. Here you go, everybody in the chat. Here is a URL to the cheat sheets.
Yes, the cheat sheets have a Gremlin API cheat sheet in there, which does include things like grouping and order. So for the aggregates in this case, I want to get all of the counts of the talks by track. This is what that syntax looks like. So get the vertex, get all of them that are talks, group them first by track, and then by their counts. So I have it ordered by the track, and then you can see their numbers. That by track and then by values, you have to do the grouping that way. If you were to do a group.by and then .group.by, that second group would reset your grouping altogether. Same thing with order. So I have done that before. I have been bit by that before. We want to try to avoid getting bit by that again. Okay. Ordering, this is what I was talking about with like ordering by. You can do various things with order by. So if we wanted to get the talks values and order them by name, we could do that. Notice here that I've got g.v.has label talk. So get only the talk vertices, order them by their name field, and only get the name as the output. Same thing, first 5 talks. So if you want to limit your queries, you can do that with .limit and just pass in an integer value for that. If I wanted to order them by a different field than name, whatever you want to order them by, you can. Now let's combine filtering and ordering. And what does this look like? So suppose we want to order by the track number and then by the name. Notice here that I have order and then .by and then .by again. You don't want to repeat order in there because as soon as you repeat order, it resets the ordering. So if you're stacking by multiple fields, then you just stack the by clauses. Don't repeat order. Same thing you'll see here later on. Ordering the tracks by time. There's a reason why I used the 0900 notation, and that was so that they would line up by time nicely. All right, mapping properties and values. So value map, what's nice about this is that you can say, okay, so this query, I am looking for all talks in track 2 ordered by time. The value map then shows the property and the value. Again, this is when you're consuming the results in code, making it a little bit easier. This is just JSON out from the API, so you can see what to expect from the API. Now, whether you're using Gremlin Java, Gremlin Scala, Gremlin Groovy, Gremlin Python, Gremlin .NET, this is the stuff that it's consuming. All right, I have 2 main queries I want to show that are here back to back. Jay, if you can hide me, so we're just looking at the slide. There we go. We can see the text underneath me. All right, so if you like this talk, so the recommendation engine portion of this data, it was if you like this talk, you might be interested in other talks. So what we're doing is we're going to, I'm going to grab my laser pointer to walk through this. So you might also like other talks. So you're going to start here with g.v.has this name. And then we want to find all of the edges that are coming into this. So we have Azure and Azure Cosmos DB. They're topics that are both covered by this. Once we get to their in E, next we want to get out V. So we want the vertices that are at the other ends of these relationships. That's what this out V here is. Now, Azure, I know, has a bunch of other talks. Azure Cosmos DB, this is a new one I didn't build relationships for, but Azure has other talks. So out E is going to gather all of the other edges that come out from Azure in addition to this one. And then we want to find the talks that are also Azure related. So the NV, which will get this one plus anything else. And what talks belong to Azure? What are their names? So these are other talks. Because Intro to the Graph Databases using Azure Cosmos DB Gremlin API is in the Azure category, you might be interested in other talks in the Azure category. So this is how we walk through that. So does it help to see with the laser pointers I'm pointing as we navigate through? It gets a little tricky with that because you're in E, out V, out V, out E. Which way am I going where? You kind of lose track of it. Now the query, you can run that path and it will show you the steps that it took to get from one end to the other. But the other query that I want to show is the execution profile. And the reason why I like showing the execution profile is because it breaks down the steps and their usage. So you can see how expensive is this query going to be? How many resources, how much resources does it use? It shows the total time. In addition, it shows the steps that it takes. So you can see that it gets the vertices, it gets the edges, it gets the neighbors, it gets the edges, it gets the neighbors of those, it gets the values for a property. And this project operator is the execution profile. So this breaks it down, and these details for these steps are included as well. All right, I know we're short on time, but there are some links. Again, there's the Cosmos DB cheat sheets. Love those things. Regardless of which API I'm working on, they all have cheat sheets. So check that out. The graph support and compatibility with Tinkerpop features. I don't have any demos where I break against my Azure Cosmos DB Gremlin API. However, if you are used to Tinkerpop, there are some things that aren't supported, so make sure you check out that link. Practical Gremlin, great tutorial for learning Gremlin. And then there's another Gremlin cheat sheet by Daniel Kupitz that I refer to as well. But those are the links that I have. This is a quick intro to Gremlin and some of the queries and what it looks like with Azure Cosmos DB. If you have any questions, I was on the Data Weekender bus. I was on Data Weekender, but I am also here in the Azure Cosmos DB community. Feel free to reach out to me. I'm Saduki on Twitter. I am Saduki through LinkedIn. My dev blog is saduki.com. I foolishly started a data blog thinking that this year would be all about data. And then I got a bunch of dev projects on my plate. So the dev blog came back to life.
Well, thank you very much. I think we've learned a ton from you today. I really appreciate your time, Sarah. People want to get in touch with you. I think one of the best ways they can do that is on Twitter. Here's your Twitter. It's Saduki. It's really, really a great place where, you go. Sarah always is giving us great information, trying to help the rest of our community. And that's what this is all about. And specifically these meetings, the fact that we were able to kind of present some information, take some questions, learn something, and, grow our skill set to continue building amazing applications using Azure Cosmos DB. So Sarah, do you have any upcoming talks or anything you want to just mention before we close out?
So the upcoming talks I have include this talk and a version about barbecue. And so what barbecue is going to be right for you? That's happening for TDevConf. It's a virtual conference. That's on September 30th. Other than that, nothing else that I can talk about just yet. But if you stay tuned to Twitter, there is more to come.
Awesome. Hey, thank you so much. I really appreciate your time today. I know that our community always appreciates what you do for it. And, that's really it for today. Thank you.
Oh, thank you for having me. And thank you all for coming.
No problem. Everybody, we are going to say goodbye. It was great being here with you and doing all the things that we could to learn more about using the Gremlin API, learning about Tinkerpop, all these things which, help you build better. So until the next time, Sarah, why don't we give everybody the big wave goodbye?
See ya.
Take care, everybody. Have a great rest of your week, and hopefully a great fall now here in the US, but wherever you are, a great new season. Take care. Bye now.